Okay, 5.4, evaluating exponents and radicals. Students will be able to evaluate expressions that involve rational and or negative exponents and radicals. So here's the trick. I want you to look and see what do they have in common, and then that'll tell you what rule to use from either 5.1 or 5.2. So let's take a look at the first one here. So what do they have in common? Well, the thing that they have in common is that they have the same exponent. So that means the first thing I see then is that we could write this as 2 over 16 in parentheses to the negative 4/3. Okay, well that obviously reduces to 1 over 8 in the parentheses, negative 4/3. Now what does the negative mean? Doesn't the negative mean that it's the reciprocal or that we flip it? So really this is the same thing as 8 over 1, or just 8 to the positive 4/3. Then if we wrote it as a radical, it'd be the third root of 8 to the 4th. I like to do the root part first, just makes it a little bit easier. Third root of 8 is 2, and 2 to the 4th is 16. And boom, now we've simplified this thing down. So, take a look at that. I want you to try practice number 1 on your own. It's very similar. Give it a shot, and then check back to see if you did it correct. Alright, so again, the exponents were what matched. You could write it as one single fraction in the parentheses. If you divide that, you get 49, but it's a negative exponent, so you can just flip it, make it a positive exponent. The 1 doesn't really matter, it's just going to become 1. 49, it's the same thing as saying the square root of 49 to the third power. Well, the square root of 49 is 7. 7 to the third is 343, so that was all on the bottom. So the answer is 1 over 343. Let's go on to the next one. Okay, this one at first glance doesn't look like it has anything the same, but remember that a 1/2 exponent is the same thing as a square root. So if we were to convert these to both square roots, what we're really dealing with here is the square root of 72 over the square root of 2. And you can actually write that as one square root, 72 divided by 2. Well, 72 divided by 2 is 36, so you have the square root of 36, and the square root of 36 is 6. See how that's done? Alright, go ahead and give practice number 2 a shot. Again, it's very similar. Okay, so you got square root 5 now. So we got that because, yeah, this is really just like saying square root 75 over square root 3. You could make it one square root of a fraction. 75 divided by 3 is 25. Square root 25 is 5. Easy peasy. Alright, one more here for you. Okay, on this one, the thing that they have in common is actually the bases, right? They have the same base. So what we can do is we could subtract exponents. What would that look like? Well, that would look like saying 27 to the negative 11/12 minus the exponents on the bottom, and the exponent on the bottom is actually a negative 1/4. Well, double negative makes a positive. I'm sorry, that's supposed to be a 12. And we can't really add these fractions until we get common denominators. So what we're going to need is to multiply the top and bottom of this by 3, so we get common denominators. And when we do that, we would really have 27 to the negative 11/12 plus 3/12. Okay, well, negative 11 and positive 3 makes negative 8, so this is really 27 to the negative 8/12. Well, 8/12 reduced, so that would become 27 to the, take a 4 out of both of those, that's negative 2/3. Alright, what's really a negative 2/3? Now we can go back to use all of our rules. Well, negative 2/3 is really like saying 1 over 27 to the 2/3. And that's like saying 1 over the third root of 27 and then square it. Well, the third root of 27, that's pretty easy. That's 3, and 3 squared is 9. So all of that is 1 over 9. Pretty fun problem, lots to do there, but all I did is my rules, right? So first thing I saw is that when you have the same base, you can just subtract the exponents, which I did, but it was negative, so we added. Then I got common denominator, so I could add them. Then I reduced. Then I applied what a negative was. Then I applied what the denominator in an exponent does, which is really the root, and the top is really an exponent. So there we go. All right, one more for you guys here on practice 3. Give it a try, very similar to the last one. Alright, so again, we have the same base, so we can subtract these exponents since we're dividing. We need to get common denominators to do so. When we do, we get negative 9/6, which reduces to negative 3/2. The negative means it can really be put on the bottom. The 2 on the bottom really means it's the square root. So the square root of 81 is 9, and then you raise that to the third power. 9 to the third power is 729, so this whole thing is just 1 over 729. Alright, that's it for this video. Just using your properties to simplify things down until you get to one nice, neat number. See you guys on the next one.